Start streaming. Where is. There we are. Hello, hello. And, well, let's do some more Vulkan. A little more. Um, I think last time we may have ended up here. And we're gonna check. As always. Oh, yeah, you're my hero. Does everything build and work as expected? Uh, Looks like it. So we have some form of texturing as well as color blending. Blending? I'm not sure. Well, whatever. Um, and we were at the verge of depth buffering, but for some reason, let's just check something out really quick. It makes perfect sense. So going up, doing this. Well, never mind. Good. Let's just check depth buffering. We worked so far. Da, 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 da. Okay, now we need obviously three-dimensional positions. Let's see. Now we got there. Oh, let's just do this. It's now 3D. And 0 dot. I think we can. Ka-ching. And duplicate all these. So now we have 5, 6. Oop. So let's have 2 triangles. And these are now three-dimensional vertices. So, okay. And we need to also change this in here, I guess. In position is now a vec 3. And so this needs to be done. And I think we don't need to drag color texture out. Here's no change whatsoever. That's good. And so we changed this, we changed it, we did this. Yeah, made our vertices. Exactly. I think force radiance is no longer depth 0 to 1. So, before we do all that, we want to see whether it works. Rebuild shaders. Yeah. So, but we want to make the depth buffering a little bit, the lack thereof, actually a little bit more visible. Should we, I like the symmetry of this. So let's, has to be something. Um, okay. That probably didn't change anything. But we will see. Hmm. It should not. Just want to check what happens if the up vector is the same. Okay, but now we accidentally, that's not the right thing. We want to see it moving more awkwardly. No, that is not really what we want. Does this axis have to be normalized? I'm not sure. Let's just play around. I want to have it tumbling in a way that one can actually see that there is no depth buffering now. I think now we're just well, we will see. Let's continue. Let's continue a little bit. So we did this, we did this, this we had. Yep, we know this. So we need a depth image. Okay, let's take all of these guys. Um, Depth image memory, depth image view. That create depth resource. Mm. So, so I think we already have a find supported format function. So, yeah, good. Device properties, tiling, find supported format features. So, and maybe we even have a find depth format. Find supported format, find depth format. That's what so we implemented that beforehand in some earlier. But I think that is what we don't have. So as stencil component. So static VK format. Now we're stealing this guy. So um, VK depth stencil bit. We have a depth format. I think we also already have that as part of the swap chain creation. So let's just check. I think we already have a member for that. Yeah. Find depth format. And it's part of the physical device. Good. All right. BK format. Depth format. Picked physical device. Yeah, there we already have it. So we don't need to do any of that. We evaluated that beforehand. But this is what we need. Okay. Create image. Depth image. Depth image. Memory. Okay, the Vulkan context itself. Now this is PC. I think we have. Maybe we have that here, of course. That's what we want. Swap and extend. PC. And the height. Okay, format. Depth format. Hello, while we're at it, just remove this and replace this. Copy paste. How hard can it be? So, but so tiling. Obviously, we want this to be optimal. Usage. Depth. Stencil attachment bits. And device local. That's what we want. So if check lock, if something happens, we're out of here. So don't think we need this any longer, but you need to image aspect. So create image view. Aspect flags and aspect color bit. I think this is what he meant. Right? So create image views. So we need all the calls to that. Recreate swap chain. Color bit. Extra image view. Color bit. Wait, what is this? So recreate swap chain. This. Okay. Can technically steal that thing. Huh. Depth image view. Depth image. I think this will be one. Format. This is now the other thing. Aspect depth bit. Okay. Let's quickly do this before we forget that. Memory. Let's see what the image view does. Ugh. So, depth image view. So, make a call. For completeness. Mhm. Oh, alrighty. Transition. That's exactly what I want. So, so we have the context, depth image. Then we have pick the depth format. So, depths, stencil optimal. Righty. Now we have to change this. The undefined layout can be used. See. So let's so so where does this go? If New layout. Optimal. Oh, wait, we need to change this in the. Where's the barrier? There is. Okay, we don't really need that. IMB sub resource range. If alrighty. Stencil bit else. Okay. I may have messed that up here somehow. Think we may put this. Go away. Color bit. Da, da. Okay. Let's see where. Um, split. So hmm. There's the and then new layout. Okay. So layout undefined. Okay. Make some room here. new layout, barrier, access image right, source, stage, destination stage. Okay, that doesn't change. Else if old layout. Oh, wait a minute. No, this is true. So this is here. And a new layout. Transfer bit there. Pipeline this. That's there. Alrighty. So else if old layout image layout undefined new layout optimal source IB 0 0 test access mask oops pipeline top of pipe bit early bits. Okay, so I think we wrangled that in somehow. We can get rid of this. To include a depth attachment, first specify attachment description. So I think we already have a description here. Static. I think this is not well named. Attachment reference. Um, Depth attachment. We can use this. Depth. So clear. Store up. Oh, wait a minute. This we copy and paste it. So we have samples, load up. What's this? Store operation is attachment store don't care. Stencil load up, stencil store up. Initial layout undefined. Final layout is something else. So optimal. Right. There's no other flags or anything. So okay, so it really only has these two members. That's great. Attachment. One. Layout. Subpass description. Depth attachment. Okay, color P, depth stencil attachment. Depth stencil attachment. Depth. Okay. And that is the attachment reference and not the actual description. So, all right. Mm-hmm. Render paths. I think I need to. Ah, let's see. Let this and then render pass create info. We are here. And we need a bunch of attachments. Color attach. Okay. I think we name this color. So this is color. I should probably. Attachments. Mhm. So these might not be copyable. I need to do it like this. Yeah, there was something. I think we want to change this a little bit. That's um don't like the duplication anyway. So um no. Okay, these are ADs. ADs, but I still don't like it. So we're gonna change this up. These are the references. Attachments. So zero. Use depth. Hmm. Depth format, depth stencil. So yeah. So these guys can hopefully go home. Attachments. So attachment reference. Don't need this anymore. Yeah. So this is the subpass descriptions. These are the references. This can go home. Attachments. Good. So So subpass and dependency would stay the same, but they're. Oh, I need to decay subpass dependency. Source stage mask. Pipeline early test bit. So early stage fragment bit. Test access math. Depth stencil right bits. Bit. Hey. Okay. Frame buffer. Oh. Okay. Before we do this, will it compile? Yeah, more or less. Good. What is this? We don't need that. So, oops. Create frame buffers. Swap chain image views, depth image view, and then frame buffer inf. Okay. Okay, these are really just image views, so see depth image view. Depth. So I think the rest stayed the same. So Maybe we should make this explicit. Yeah, we did the other ones. We did it explicit as well, so might as well. I think then we can also pull this out of here and make it static. Good. And attachments. Good. Now we obviously need to create that thing first. Create depth resource. Create frame buffers. Of course, we are. And we could, no, that doesn't. That's fine. Let's just not overdo it, overcomplicate things. So, record command buffer. I think we already did this. Yeah, but what we didn't do, vendor pass info, clear values. Ah, clear values, and we have, oh yeah, I already know. So, thought about that. Good. We still need to enable it in the graphics pack. shader. Pipeline dynamic. You depth stencil. Do we actually color blend layout? Okay. Layout create. I'd say we place ourselves right here. This moment in time. So pipeline depth stencil state create info. So that's nice. So type as usual. Next is as usual. Well, don't think we have any flags. Depth test enable. So we have this depth compare up. Depth compare up. Bounce test enable. Min depth bounce was this, if I'm not mistaken. So, min max stencil false. Okay. Oh, stencil upstate. To find out what that is. So depth stencil state. This is pipeline info. Mhm. So okay. So and we need to clean up. Okay. Mm, are we doing this? Oh no, wait a minute. Yeah. Alrighty. And then recreate. I think we're a little overboard here. Shouldn't just use the global instance here. No, 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 no. That's not what we did. Okay. Does this compile? Ah, okay. I see it all your way. You need to shift this up. Huh. Before. Wait, I gotta be careful. Buffer to image, buffer. Code, where is the command buffer render pass pipeline? Where is the frame buffer? Well, that probably won't help. Yeah. Clean up, swap chain, create image. Yes, so we need to transition. At some point, we may want to start and creating prototypes for these functions, but no. Ah, damn it, damn it, damn it. So create image. Where is the create image function? Just find memory tab. Okay, create buffer. Can I move them all up? I sure hope so. Yeah. I don't wanna. I need to think about the layout anyway, and just if that's it's. Let's just grab this guy. Let's have some prototypes, but maybe after the global block. Should have done that the first place. So alrighty. Hmm? Create image. Maybe the swap chain extent isn't there. This is probably some order issue. So yeah, the common pool isn't there. So we need to create this guy a little earlier. I think we should be able to create it rather early. What does this thing depend on? Oh, we have that. Then we say pool. Okay. Other than the Q families and the device, we don't need anything. Good. Mhm. Okay. Wait for fences. There is stuff going on that isn't kosher. I don't have that. Does not match the format. Okay. Oh, the okay. We currently depth format usage depth. Create image views. Wait a minute. So we do this, and this is obviously wrong. No. Okay. Let's just see. Uh, we built. Okay. That looks like some form of depth buffering. Are we being yelled at by the validator? No. Not as far as I can scroll back. Okay. Now that is odd. Alrighty. We don't want to do that at this point. That's not what we want. Oh, I mean, this is a lot of reworking. We could, I mean, well, technically, we never ever want to do real-time map generation. We always bring fully map textures if we have to. We this techno, although at some point we need. Let's see. But that is also not something. Okay. And then what happens? At some point, multi-sampling. Now that might be something we at least want to take into account. So okay, maybe another time we can do this. Alrighty. Maybe even today, but definitely later. Um, so, maybe I should find out something else. Where? Ah, there. Why? Why didn't the generator work? Let me check here. So we're just copy and pasting this. We gotta get rid of this. Then okay. Oh yeah, and now we also get libm. Why didn't this work yesterday or the day before yesterday? Maybe I typoed or something? Okay. We can get rid of that. That is nice. Um, oh yeah, maybe. Okay, that but that. All right, good. Git status dash u. La la la. Oh, there is nothing out there. Okay. Well, it's doing great. I mean, I uh, I just added the depth buffering here, and so depth buffer should work. Yeah. So so far we're good. Um, now we're follow the tutorial with a you know, but I think I will continue this later. Yeah. Yeah, I mean I'm thinking of skipping a few chapters from the tutorial, but I'm not. I haven't. I really need to think about it a little more because I don't really want to do this level model loading part in here. Um, well, for starters, I think the tiny object loader is C++, if I'm not mistaken. But I may be wrong. I haven't checked. And I don't really. I mean, yeah, that looks very C++y to me. And I don't really want to, I want to make my own models. Yeah, I know there's tons of code out there, but I think it will be quite some time before we even come to contemplate sort of with actual 3D geometry. I want to mostly keep things 2D, and at some point you obviously have to directly export model information from Blender or some other thing. I think I will, but I will do this at a much later stage. So at this point, I don't really want to do any of this, you know. And obviously, I mean, and this just kind of, removing double vertices and what I mean, you want to do a lot more than just that, right? You want to have some form of like there's an NVIDIA triangle strip library, or so there's some sort of NVIDIA library out there that sort of optimizes vertex buffers, sort of making sure that as many vertices are sort of more cache fit than others. I don't NV tree strip or something. I don't know. I don't remember what's called, but I know that there's lots of code out there that sort of try to create optimized vertex buffers. But for two rectangles, it just really there's not really a point in doing so. But yeah, at some point, mesh or model loading will definitely be a thing, but not for now. And the same is technically true for mipmaps. Automatically generating mipmaps is usually, I mean, yeah, I think I will do this next, but just so to have it out of the way, and it requires an awful lot of code changes as well. Um, but in general, I don't think one wants to even have that in your code because you will obviously, an artist might want to have fine grained control over the maps themselves. So it's not really, it's automatically generating them. That there's all these are steps that you should do before, you just load ready-made mip-mapped textures, not trying to automatically generate them. That's it's. But it it's of course an exercise as well in Vulkan with all the transitioning, so it might be a good idea to do this. But as I said, I will do this probably in the next stream. Um, but yeah, and then of course multi-sampling of some sort will have to follow. Yeah. And then we can finally start to dissect the entire thing and make it so that one can have multiple pipelines and sort of, the thing that you would have in an OpenGL kind of rendering fashion where you simply want to, you know, render a variety of objects, not just sort of two trying. And this is, at least when you follow the example, I think the first time it's not necessarily clear what you have to do to render multiple objects or to kind of, render a bunch of sprites or render a bunch of three-dimensional objects. What if they don't share textures? How do you switch between these things? And yeah, but we will, that will be way later, way, way later. So yeah, but for now, as I said, we have a depth buffer, and I also need to restructure the code a little bit. Yeah, so yeah, but I think well, oh yeah, I want to submit this. What does it say? One last time to. Okay, we're rebuilding this. We rebuild the shaders. We run and it works. Good. So we definitely want to submit stuff that is functioning. So git commit add depth buffer edit depth buffer a depth buffer. So now I have to look into my cheat sheet. How do I? Yeah. Git push origin main. That would be this guy. And we're copy pasting that. So now it's on GitHub. Well, I'll probably be streaming in a couple hours again, but for now, there's still other stuff that I need to do. So I just wanted to do a kind of early morning, well, or morning is the wrong word, but sort of, yeah. So, well, having said that, yeah, see you later and have fun. Stop streaming.